Okay, so we've looked at defining and counting and rounding significant digits.
Taking measurements.
Taking
and
measurements.
Also rounding them after you do the measurement.
And we're just leading that up to here because eventually really what we're trying to do is set you up so that when we start doing math problems, you know how to count the digits in the math problem and how to round the digits out of your calculator, because you need to decide which number you need to round. In the last lesson, we told you where to round, but this kind of helps you figure out where you need to round yourself, so you get to determine that. Two rules that we need to learn and be aware of. The first is the plus or minus rule, anytime we add or subtract.
Okay, so the rule is that we round the answer when we add or subtract to the same number of decimal places as the term with the least number of decimal places.
Okay, so we want to find the least number of decimal places, and then we want to round
to that number of decimal
places.
places.
Number of decimal places.
So our first example here, 1.01 plus 2.5.
So if you put this in your calculator, no, you want to do it in your head, unless you're Mr. Manor and you can't do math in your head. You get 3.51, but that is not all accurate.
So we look at this, we're counting the number of decimal places in each of these. There's only 2 decimal places in the first one, and there's only 1 decimal place in 2.5.
That means the next decimal place here, the second one, is unknown. So here's how I like to show it. If you put these vertically and you line up the decimal places just like you would in, I don't know, elementary school?
3rd grade maybe?
3rd grade.
Maybe.
You get 1.01, 2.5. The decimals line up, but there's an unknown digit here. It's a question mark. We don't know what comes after the 5. So even though your calculator gives you 3.51, you cannot say that 1 plus an unknown equals 1. So we want to cut that off, and the answer is just 3.5.
Nice. I like that way of explaining it. Nice and clear.
So even though I have 2 decimal places here, my answer can only have 1, so we have to round it. Since that 1 is less than 5, we just say it's 2.5. We do use that 1 to round the 5, but we don't put it in the final answer.
The key here is that we can only be as accurate with our answer as our least accurate measurement. So our least accurate measurement only had 1 decimal place, so our answer can only be as accurate as that 1 decimal place as well.
So 1.01, there's 2 decimal places there. 0.0004, 4 decimal places there. If I line these up, 0.0004. Well, there's an unknown digit here and here. So these really aren't significant. They're not going to matter in our final number. We're going to cut it off at 2 decimal places.
Hey, look at that. The answer is the same as one of those terms that we added.
So only in chemistry can you add something to a number and get the same number back if your digits are not significant. You remember that joke we were talking about with the pyramids? 6,000, this applies the same way without decimal places. You can't just add 5 years to that because this is an estimation. It's only significant to here. This number here is unknown. We don't know if the pyramids are 6,527 years old, 6,534. We just know, we say about 6,000. So the pyramids are still 6,000 years old. They're not 6,005. That 5 didn't matter because the zeros, the placeholders, are not significant. They're unknowns.
All right, so multiplication and division, the rule here is that we round the answers to the same number of significant figures as the term with the least number of significant figures. So it was just decimal places with adding and subtracting. Now we're doing significant figures again.
And we're looking for the least number. So now we actually have to count them, not a decimal place rule. This one's actually a little easier, and we're going to do it more often. Multiplication and division. Here's an example. 2.147. How many sig figs are in that number?
4.
4. 1.02. How many sig figs are in that number?
3.
3. You guys are awesome. 4 here, 3 here. My answer can only have 3 sig figs. You pick the one with less. Plug that into your calculators. Get out your fingers and toes.
So the calculator is going to give you something like 2.18994.
Okay.
We just learned that you have to round that number.
But your calculator's not intelligent. We are. 3 sig figs. The first 3.
Well, your calculator's artificially intelligent.
Artificially.
We're naturally intelligent.
Yeah. 2.18. Anyways, there's our first 3 sig figs. That 9 is still going to help us round this, but we don't need to include it. So really we're going to round that to 3 digits, 2.19.
All right. That looks a lot better than 2.1899.
This is the answer. All right.
Okay.
Okay, second example. Now this one's tricky. You have to look at it very carefully. 182,000, whole number, right? Zeros aren't significant. Except for that little decimal place right there.
Ooh, that sneaky little decimal.
There's nothing to the right of it, but that decimal tells us that these zeros are not placeholders. They're actually measurements, and they're significant.
So that 182,000 actually has 6
sig figs
significant
because of the
figures.
decimal. 5.20 decimal, they all matter. There's no zeros out in front. That's our decimal rule. That only has 3 significant figures. Get out your toes, count your fingers. You get 946,400. So there's my answer. Nope.
Oh, we got a round
3 sig figs.
to 3 sig figs.
3 sig figs. 946. The 4 means I leave it alone. Does not get rounded up. But it does become a placeholder. Because
All right, so we got to have the placeholder there.
Placeholders are not significant.
Can't just round 946,000 off to 946.
Nope. Placeholders matter.
That's crazy
So
talk.
they're not significant anymore, but they're placeholders.